Okay, so this is IBDP Chemistry HL October 2025 paper. Question number one is which methods for separating the given mixtures into their components are correct? So number one, a mixture of solid and liquid in which solubility of the solid varies with temperature. It's a crystallization. It's a crystallization. Yes, this is correct. Let's say I have sodium chloride, which is dissolved in water. So sodium chloride is soluble in water. Okay, let's say I have sugar. It's also dissolved in water. So sugar is solid. Sodium chloride is solid. It is dissolved in a liquid that is going to be water. So if I'm going to separate it, so this technique would be crystallization. Also, it would be simple distillation as well, right? And also a mixture of a solid in a liquid in which the solid is not dissolved. I mean to say insoluble particles. If you are going to separate insoluble particles from the liquid, so this technique is filtration, like filtration. This is correct. And a mixture of two miscible liquids with different boiling points. When the two liquids have similar boiling points, similar or different boiling points, let's say if I'm going to separate alcohol from water, the boiling point of water is 100 and the boiling point of ethanol is 78. So the difference is around 25 or 27 degrees Celsius. So if you're going to separate these type of liquids, so this technique is called distillation. Okay, so this is also correct. So the answer is going to be D for doctor. All are correct. And chlorine is a diatomic molecule that contains 75% of Cl35 and 25% of Cl37. Which graph shows the full spectrum of chlorine? Number one thing is that you need to know how many peaks we would be getting in the case of chlorine. Of course, five. Of course, five. Why? Chlorine 35, 35, chlorine 37, 37, chlorine 35, 37, chlorine 35, chlorine 37. So there are five peaks in total. There are five peaks in total. So in all of the spectrum, I can see 1, 2, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. It seems like that they all are correct, but no. The thing is that for the two peaks, which is 35 and 37, the ratio of the peaks are going to be 1 is to 3 or 3 is to 1. And remaining other peaks, I mean to say Cl35, 35, Cl37, 37, Cl35, 37. So the ratio of the peak is going to be 9 is to 6 is to 1. 9 is to 6 is to 1. Okay. Abundance of chlorine 35 is 75%. So its peak is going to be 3 and this is going to be 25%. So this is going to be 1. 3 is to 1. So that's the reason the peak that is of 35 is abundance, which is of 3, and then this is 1. So this is 3 is to 1. And if you're going to discuss this, it's going to be 9 is to 6 is to 1. So means A for apple is correct. Why B is not correct? Yeah, I'm getting the same peak. 9 is to 6 is to 1. But this is 1 is to 3, which is completely wrong. This is having the lower height. Why? This is 35. Its abundance is higher. It should be greater than the 37. So this is wrong. Why C is incorrect? This is good. Yeah, this is 3 is to 1. But this is incorrect. Okay. The ratio is going to be 9 is to 6 is to 1. Not like this one. Not like this one. So you basically, before going to do this question, one is chlorine and one is bromine. You must do working for the chlorine and for the bromine. You need to know very well regarding the mass spectrum of chlorine and the mass spectrum for bromine. Remember, okay? So for the chlorine, You must know the peak heights. You must know the peak ratio. So number one is that it's going to be 3 is to 1 and it's going to be 9 is to 6 is to 1. Then you can compare the known ratios with the given spectrum and then you can get the final answer. So the answer is A, not B, not C, not D. Okay. So finally, if I can summarize it, you must memorize the mass spectrum of chlorine and the mass spectrum of bromine, each and everything regarding the ratios, regarding the peak heights, everything you need to know. Okay. Otherwise, when you will see the question, so you have to do the working that would take your time. Okay. So question number 3, which orbital diagram represents a correct ground state electronic configuration based on the Pauli exclusion principle and Hund's rule? So the thing is that first of all, we have to fill up the orbital in a single manner, like single, 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 then double, then double. The second thing is that first of all, we have to fill up the orbital in upward direction like that. Okay, so which orbital diagram represents a correct ground state? This is wrong. You know why? These two are upward and this is downward. This is wrong. This is against the rule. This is against the rule. Both are upward. No, one is upward, one is downward. Okay, this is incorrect. This is incorrect. So, and also now we have to look at A and D for doctor. This is also incorrect. You know why? First of all, we have filled it up singly, single, single, single. But why this is downward? It should be upward. The first electron should be upward. And when you will be filling the electron doubly, so then it's gonna be downward. So this is wrong. So finally, D for doctor is correct. This is according to the rule. This is according to the Pauli exclusion principle. This is according to the Hund's rule. Okay. So again, the simple is that you must know about the Pauli exclusion principle and then Hund's rule. So I'm going to summarize it. First of all, you have to singly fill the orbital. Like let's say if I'm having p orbital and I'm going to fill it up. So I can't do like that. I can't doubly fill it. You know why? First of all, I have to fill it single, one, one, one. Then if I have extra electron, then I'm going to start in a double manner. That's the concept. And number one thing is that if I have three electrons, so first of all, one, then two, then three. If you are going to fill in this manner, one, two, but downward, this is wrong. This is against the rule. So 5.72 grams of sodium carbonate is dissolved in water to prepare zero point 0.4 decimeter cube of aqueous solution. What is the concentration of sodium ions in mole per dm cube in the resulting solution? So first of all, what I have to do, you know, they have given you the volume of aqueous solution. They have given you the volume of aqueous solution, that is zero point 0.4 decimeter cube of aqueous solution, and also they have given you the total mass of Na2CO3 dot 10H2O. First of all, I'm going to calculate the moles. Mole of Na2CO3 dot your time is equal to mass over mr. Mr they have given, that is 286. So the answer is going to be 0.02 mole. 0.02 mole. What's the mole ratio between this compound and the sodium ion? Of course, 1 is to 2. In this compound, it has 2 moles of Na positive ion. If I'm going to multiply this by 2, I would be getting the moles of Na positive ion. I have taken the mole ratio, right? Then I'm going to find out the concentration. Concentration is equal to mole upon volume. Mole is 0.04 divided by the volume, that is 0.4. If you are going to divide it, you would be getting the concentration that would be in mole per decimeter cube. So the answer is D for doctor. Okay. So, and then in which of the following sets of conditions does the gas exhibit behavior closest to an ideal gas? So number one thing is that which is the ideal gas in which there is no force of attraction. The ideal gas is the one in which there is no force of attraction, negligible force of attraction. Number one, we have hydrogen, ammonia, hydrogen. Ammonia is having hydrogen bonding. It's completely wrong. It can't be an ideal gas. It may be A, it may be C. It may be A, it may be C. Right. So this is higher pressure. When the temperature is higher, when the temperature is higher and lower, so we need to know at what temperature, at which temperature and at which pressure there is an ideal gas. Okay. So again I would tell you that we must know about the temperature and about the pressure. If the pressure is lower, what does it mean? The volume is higher. The particles are far away from each other. There is no force of attraction, isn't it? Am I right? I'm repeating. Number one, when the pressure is lower, so the volume is higher. When the volume is higher, so the particles are far away from each other. When the particles are far away from each other, so there is no force of attraction. Secondly, when the temperature is higher, so the kinetic energy is higher. And when the kinetic energy is higher, so the speed of the particle would be very high. When the speed of the particle would be very high, so it means that there would be no force of attraction between the particles. So it's gonna be an ideal gas. That's why C for cat is correct. A for apple is incorrect. So the answer is C. Okay, right? Then they are saying an expanded view of the NaCl lattice is given in the figure, and which statement is correct for the lattice structure of sodium chloride. So for this structure, I would say number one, the ions are held together in a lattice by a covalent. Oh my God, this is wrong. It's not a covalent bond. It's an ionic bonding, right? So the force of attraction in the lattice are very weak. The forces of attraction in a lattice is very weak. No, it's a very strong force of attraction. Each sodium ion is surrounded by four. No, the sodium ion is surrounded by six chloride ion. Six chloride ion. Remember, six chloride ion. Okay. And also the structure, of course, D for doctor is correct. The structure breaks apart when dissolved in water because ionic compounds are completely soluble in water when you will be dissolving in water. So the sodium chloride would be breaking down and to give you the ions of Na plus and Cl minus. What are the electron domain and molecular geometries of IF4 positive ion? Electron domain geometry for IF4 positive ion means that we have to count the total number of bond pair and the total number of lone pair, right? Bond pair and lone pair. So IF4, I means it's going to be how many electrons are there in an outer shell? 7 electrons because this is in group 7. So 1, 2, 3, 4, 5, 6, 7. So if I can say it has 5 bond pair and 1 lone pair. It's gonna be trigonal bipyramidal. It's gonna be A, it's gonna be D for doctor. So molecular geometry is seesaw. It's not a tetrahedral. Remember, it's not a tetrahedral because it has 1 lone pair as well. It would be if it would be having only 4 fluorine, but it's not right now. It's a seesaw. So A for apple is correct.